Okay, well, the very first thing that we need to do with statistics is learn the language of it. So we're going to have a bunch of definitions within this section. Okay, the first one is data, and that's just any observation that has been collected. Like I can go around a room and I can get everybody's hair color, have them write it down and pass it to me, or everybody's weight, or everybody's height. But all those numbers or all that data that I'm collecting right there, that's just what it is. That's data. I'm getting information about something. And a single data value, like one person's weight or one person's height or one person's hair color, that's a datum. Okay, and then statistics with an S, okay, it's going to be different from statistic. So make sure if it's got an S, then that's just a really broad term. It's talking about collecting all your data, and once you have it, okay, we're going to analyze it, put it into graphs, and then, okay, from those graphs, we're going to summarize what we saw and interpret what we saw, and from our interpretation, we're going to draw conclusions from our data. That's basically this whole class of what we're going to be learning is this right here, collecting, analyzing, summarizing, interpret, and drawing conclusions. That is this class. So statistics with an S is the broad spectrum, okay? Then we have two different types of statistics. The first one is descriptive statistics, and so that's just organizing all the data that you just collected and then summarizing it. So really what you're doing is you're putting it into graphs, and you're using numbers like you're finding the mean of all the heights of the people that you collected data from, or the standard deviation, which we'll talk about later, or proportion, which proportion is really just a fancy word for saying, hey, this is just a fraction. Okay, so proportion is really just a fraction. Okay, the second type is inferential statistics. Now, this is what you're doing is you're taking something from your sample and you're applying it to the entire population, which we'll get to those definitions here in a minute. So if this is my population, say I was just looking at one class or so, so that class would be my population. Well, I'm going to take a few people from that class. So not everybody, just a few people. So that would be the sample. So all the people in this little group right here, say I find the height of everybody right there. Say the height of everybody in this sample is 5 foot and 2 inches. Okay. So what I'm going to do, I found that just from these people in here. I didn't find it from everybody. So the average is 5 feet and 2 inches. Now what I'm going to do is I'm going to extend what I know from the sample to the entire population. So I'm going to say on average, everybody in that classroom is about 5 feet and 2 inches. So see here, it says you take a result from a sample and you extend it to the population, which is what we did right here. Okay, that's called inferential statistics. Now what we're going to do with that, it's kind of making predictions about the population based on a sample of data. So usually we don't look at the entire population because number one, there's too many people or too much of whatever you're looking at, and it'll take too much time and too much money. So what we do to avoid all that is to look at a smaller subset of that, or we just call that a sample. Okay, now population, that is just the complete set of elements being studied. If I said that we are looking at a classroom, well, your population would be every single person in that classroom. Whereas a sample is, like it says right here, is just a subset or just a few from whatever you're looking at. Okay, representative sample, your sample has got to contain all the characteristics from the population. Or what we say is we need the sample to represent the population. Okay, now if I have this population, and it's going to have this type of characteristic in it. Okay, so here's my population, and the different colors represent different characteristics of that person. So we've got 3 blue guys, 4 red guys, and 1 green guy. Okay, Now, say that I got a sample from that population, and my sample is this right here. I've got one red guy and one blue guy. Now, would we say that this sample represents this population, or does the sample contain the characteristics of the population? Well, okay, we got a red guy, we got a blue guy, but I'm missing a green guy. Okay, so this green person over here represents a certain characteristic within that population. Because that characteristic is not in my sample, well, then that means that my sample is not going to represent my population. What you want them to be is close to the same, okay? Because what you're doing is, all you're doing is you're looking at your sample and you're finding out information from your sample, and then you're applying what you know from your sample back to your population. Okay, so you never look at this entire thing over here. All you're looking at is the sample and using that to represent your population. Now, if we miss out a characteristic, well, then that's going to change our numbers over here. Okay, so bottom line, the sample has got to look pretty much like the population, since that's the only thing that we're looking at, and we're using that to describe the population. Okay, a census, what you're doing is you're just collecting information from every member of your population. So if a classroom was my population, then I would get, say, the heights from every single person. And then what I just got was a census. Okay, a parameter. Notice the word in here. It's a numerical summary of the characteristics of a population. Okay, so how I remember it is P goes with P. Population, describing the population, is a parameter. Now a statistic without an S, remember statistic with an S, that was a broader term. Okay, that was back here. Statistics with an S, that is basically this entire class. Okay, what we're going to be doing in this entire class. But a statistic without an S, that's a numerical summary of the characteristics of a sample. Okay, I even have it here. Notice this is different from the word statistics. Okay, so this S goes with S. So a statistic describes a sample. Okay, so this is an overall picture of basically what we're doing. So we have a population here, and we say, okay, I'm going to find the heights of every person here, or I want to find the average heights of this population. Well, there's too many people here. So what we're going to do is we're going to take a random selection. That word is going to be important here in a minute. So notice, say it was this person right here, this person was this person right here, and so on. Okay. So we didn't use every single person. We just used a few people from that entire population. Because remember, most of the time it's either too many people, too much time, or too much money. Okay, and so we want to narrow it down, and we just want to look at a few of the people from this entire group right here. Okay, so if I take this little group right here and I find say the mean or the standard deviation or the proportion, what you would call all of this right here is a statistic because it came from a sample. Now, if we looked at the population and we found the mean or the standard deviation or the proportion, well, what we had found is a parameter because these numbers right here came from a population. Okay, so if a number comes from a sample, it's a statistic. If a number comes from the population, parameter. S and S, P and P. Okay, and these are symbols here. This is a sample mean, sample standard deviation, and sample proportion. This right here, it's a Greek letter. You call it mu, M-U. It's a population mean. This right here is sigma. That's the population standard deviation, and this right here should be a capital P. It's population proportion. Okay, we're going to go through these and we're going to say, is it a statistic or a parameter? So in an AAA Foundation for Traffic Safety survey, 21% of the respondents said that they recently texted or emailed while driving. Okay, so they put out this poll. Some people answered, some people didn't. So they said 20% of the people who responded to that survey. So it wasn't every single person. So since it wasn't every single person, this is a statistic. And the statistic is 21%. This is the number that's describing the sample. Okay, number 2. Suppose that 48.2% of all students on your campus own a car. Okay, so every single person on the campus, they looked at every single person, so that's our population. Okay, so since it's a population, this number is being used to describe that population. We're talking about a parameter. So our parameter is 48.2%. Okay, number 3. A study was conducted of all 2,223 passengers aboard the Titanic when it sank. Okay, stop right there. They looked at every single person, okay? Within our population is everybody on the Titanic. And we looked at all of them. And this number came from all of them, okay? So this is a parameter. Okay, number 4. Among the flights included in the sample, okay, we can stop right there. Sample, it's a statistic. The statistic is 21%. Okay, number 5. The mean IQ score for subjects taking the WAI scale IQ test is 100. Okay, so the mean is 100 of these people who took the test. Okay, so it's talking about, this one's a little bit tricky. It's talking about everybody who's taken the test. It didn't say there was a sample of the people who took it. They just said the people who took this test got an average of 100. So it was talking about everybody there, even though it doesn't include the word all. Okay, so since we're looking at everybody, talking about a population, that number that's describing the population is a parameter. Our parameter is 100. Okay, number 6, the average atomic weight of all elements. I can stop right there. It's talking about a population, so it's a parameter. And our parameter is, so the average atomic weight is 134.355. That's our parameter right there. Number 7, in a random sample, I can stop right there. This is talking about a sample. A number used to describe that sample is a statistic. That number is, okay, 47% of the sample households have high definition TVs. So it is 47%. Okay, number 8. Interviews of 100 adults 18 years of age or older conducted nationwide found that 44% could state the minimum age required for the office of U.S. President. Okay, so 100 adults 18 years of age or older. This was conducted nationwide. Okay, so the only people who are in there, there's just 100 people in there, but this was conducted nationwide. Okay, so nationwide, is there only 100 people that are 18 years of age or older? No, there's a whole bunch more than 100, right? Okay, so since we've only looked at 100 and we know there's so much more, or many more adults that are older than 18 years, then what we did was we took, okay, from nationwide, we took a sample from all those people and we narrowed it down to just 100. So since it's just 100, this is a sample. Since it's a sample, this 44% is really just a statistic because that number is describing a sample.